Hey everyone, it's Mike for Faraday Research. It is Wednesday morning, it's Wednesday morning, and welcome back to the channel. I just like to say thank you to all my subscribers and everybody that's been doing chats and asking me questions on the message board. Some really good stuff. So there's a lot of suggestions. I haven't replied to all of them just yet. Don't think for 1 second that I haven't read them, because I do read them. It's just there's not enough hours in the day to respond to every single comment that I get on message boards. So thank you guys for all the good info, all the great input, all the suggestions. Makes things a lot easier and gives me some ideas. So it's a collective type correspondence that we can get enlightened together. If you haven't subscribed to the channel, bottom right hand corner, also give me a thumbs up for the video. Today, one of my Patreons suggested I should use a shunt and an amp meter to actually do your testing of your loads. So lo and behold, I just happen to have a shunt, and there it is. Now, this one here, from what I understand, is about 100 ohms, 100 ohm resistance. So what you have to do is you have to hook it up to an amp meter. So I'll briefly describe the circuit. So what I'm going to be doing is I'm going to be charging this capacitor bank. Right now, it presently has about 4.3 volts in it. Okay. Now, the meter I chose, it can go up to 30 amps. That's the capability of this amp meter. I have a smaller one. Unfortunately, it got smashed in my box, so I have to get a new one. This one's pretty much pooched. So I'll have to get a smaller one, and actually this is the one I really need to actually do the testing with my motor. But I could always do it with, I might be able to get a hold of one sooner than that. Either that or I'll have to order it on Amazon or whatever. Anyways, that's one of the things I have to get, is a new amp meter. So that one's in the milliamps. This one's in the amps. So this guy here is capable of 30 amps. So I'll show you how to hook up the shunt properly. Okay, so basically the circuit is this. You got your positive wire for your power supply. So that's the input power. Input power comes into this terminal. The output of that terminal will actually eventually lead to ground. Well, eventually will lead to ground, but it's still part of the positive circuit. Okay, so it comes in positive, goes through the shunt, comes out positive again, then goes to your positive of your load. Okay, now from the power supply, the negative will hook up directly right to the capacitor bank. Okay, so that's the circuit. So from the power supply source, goes into the front of the shunt, comes out of the shunt, goes into the positive of whatever device you're testing. We're testing capacitor, so it goes in positive, comes out positive, and goes to the positive terminal of your capacitor bank or whatever load you're testing. Okay, so we're testing this guy here. All right, then from there it comes out negative, and that will go to your source. This negative goes to the source, or the power supply, which I'm using for this demo. All right, and that's it. And then you have positive and negative wires which hook directly up to your amp meter. So these terminals are for your power source. These two small ones, when you buy this type of a shunt, they hook up directly in series with the load. So what it's going to do is the shunt will provide the resistance, and then it'll go through the amp meter, come back out, and give you a reading according to the amount of resistance that's in this. And this one's 0.1 ohms, or sorry, 0.3 ohms. So when you get all your values, you could actually, you don't even need to use the amp meter. You can just do it and get your reading by knowing how many ohms resistance your shunt is. As long as you know the resistance of your shunt, you just hook up basically your meter there and do a ohms test reading. And it turns out this one's about 0.3, which means this one's ultimately was made for a milliamp meter, not an amp meter, but it will still work irregardless. It seems to be pretty accurate when I compare the amp reading here with the amp reading on the panel meter. They're pretty damn close. So that's it. It's a pretty basic circuit. So just, it's all in series. So positive coming in, positive coming out, goes to the load of what you're testing, comes out negative, and that negative terminal goes right back to your power supply. That's it. It's simple. So this is called your bar shunt. So what I'm going to do is I'm just going to, right now it's got about 4.3 volts in it. So what I'm going to do is I'm going to crank it up, and then you'll see the amp meter actually start to rise. So I got 2.5 amps going in now, which it seems to be pretty accurate. Now I don't want to go too crazy on the amps with this because I'm using very skinny wires, so I don't want to smoke them. So yeah, 1.7 amps on the power supply, and that looks about correct on my amp meter. Now if I decide to go up higher, that's 3.3. Yeah, it's pretty close. So it's about 3.3 amps going in right now. 2.8, and it's going to drop lower and lower as the capacitor bank gets filled up. So yeah, so that's how you can test your load accurately, by using a shunt. So you don't even need this meter, okay? You can just disconnect this meter, take your ohm tester, put your 2 terminals on either side, find out how many ohms resistance your shunt is, and then online there's thousands of calculators. You enter your values, how much voltage you're putting in, corresponding with the amount of ohms resistance in your load, and your output voltage. You enter all those figures in these online ohms resistance testers, or it's an ohm law meter, and it will give you exactly how many amps your circuit is drawing or creating. So yeah, it's a pretty simple process. Right now it's down to 0.800 milliamps, so it's barely reading on the meter. Barely reading on the meter. See if my camera could actually focus on it. Yeah, there we go. So I'll bump it up to, let's see, let's get it up to 4 amps. There's 4 amps right there. So it's pretty close. I think it's a little off. I might have to make an adjustment, or it could be just because the way the panel meter is hooked up there. Yeah. So it's about 3 amps right now. Yeah. I'll probably have to make a slight adjustment on that. It looks like it's off by 1/2 amp. Yeah, I have a little screw there. I can adjust the actual pin on it to actually dial in the proper amperage. And there's several ways of doing it, but one of my subscribers says, yeah, get a shunt. All right, I'll get a shunt. So I figure I'll hook this up and just try it out, see if it actually worked. So we're right around 2 amps right now. So it's pretty accurate. So I'm going to use this in my motor testing the next time I do a test. The problem is I think this amp meter is going to be too big of a value for me to do it. I figure from my clamp meter tests was showing me the output current of my pulse motor was about 200 to 250 milliamps. So this meter here would have been the best meter, but unfortunately it's smashed. It's I'll see if I can resurrect it, or if not, then I'll have to order a new meter in. But at least I know the shunt works. It does exactly what it's supposed to do. Yeah, so if you like the video, give me a thumbs up. It's a short little video, just a little tutorial to kind of add to your repertoire of doing proper testing. And I think the shunt thing is actually going to be pretty cool to use. I'll get some accurate readings on my Adam's motor output. So yeah, if you haven't become a Patreon, links are below. My Patreon and my PayPal donate is there. Some other great links are there as well. Subscribe to the channel. Refer this to a friend or a family member that's into, some cool science stuff and electrical engineering. And yeah, we'll see everybody soon.